Rapson. I'm from FCT ACTech. I'm the operations manager. And today I'd like to introduce you to the benefits of online, or sometimes called at-line, analysis for process control. So I'll just get my screen up here and we should be fine. So as Roger mentioned, I started my career working in a cement plant, and back then it had 2 long wet kilns and a 1800 tonne per day 4-stage preheater kiln system. And I had various roles at that time, which included process engineering, managing the quality, and also managing the production. So I saw the wet kilns get shut down, and also the 4-stage preheater kiln to be upgraded to include a precalciner tower, which at that time more than doubled its capacity to over 4,500 tonnes a day. So while we were in that process of upgrading the kiln, we were always looking for ways to reduce variabilities, and we certainly were trying to do that as part of that calciner upgrade project. So one of the things that we needed to do was actually completely redesign a transfer tower and had it based around the sampler. So we were very keen to analyse the limestone coming into the plant, and so we made a very representative sampling system, and as I said, we basically designed the whole tower around the sampler so that we could get that representative sample. So the FCT group was initially formed by a group of cement staff, and we started optimising burners specifically for improving the operation and reducing the fuel consumption of cement kilns. That business grew and it became known as FCT Combustion, which supplies custom burners as well as combustion systems across a broad range of industries. So we also had a low NOx burner design, and that was adapted for the Sydney 2000 Olympic Games, and that launched our career, if you like, for the FCT Flames company, which has now provided flames for almost every Olympics in the last 20 years. And FCT ACTech was formed at a similar time when we had completed an R&D program that created a new mineral analyzer. That technology has gone on to inspire a new range of online and at-line instruments for improved process control, which I'll talk about a little bit more later. So the FCT group was formed based on cement industry experience and now operates globally in cement, iron ore, lime and minerals processing industries. So the FCT ACTech division has been the supplier of at-line real-time analysis equipment for more than 20 years, and we've supplied to many cement groups globally. The range has been expanded to include cement and mining and minerals applications. It's long been recognised that process variability costs money and efficiency throughout the cement process. It reduces output, it increases fuel consumption, it increases emissions, increases the maintenance costs, and of course decreases quality. So the question is how to reduce that variability, and one of the ways is to look at some of the gurus of quality management. And of course, if you read one or two of Edward Deming's books, and he talks about single source of supply, and certainly the plant that I worked on, we did do that. We were having multiple sources of raw materials, and we were able to cut that down, which greatly reduced the variability. And the same applies for fuels. But there comes problems with that over time, and I'll get to that shortly. So really what we're trying to do is improve uptime, or making sure we don't stop the equipment, because that introduces changes. We need to try and increase the measurement frequency, And we also want to try and reduce dead time between when we get an analysis result and when we make that control action. And obviously the best way to do that is to automate that control. So online analysis provides some significant benefits. It can help lower operating costs. It can help increase the output, reduce fuel consumption, emissions, maintenance costs, and improve the quality. But what we've found in the years that we've been providing these equipment is there's a lot of other information that you can gain from the process by getting more information about it. You can see trends and understand things that were happening in the process that you never knew were going on. And certainly you are able to make more informed decisions about changeover products and try and avoid reprocessing of product, which often happens in the cement industry. There's been a couple of opportunities when plants have discovered out-of-spec material very early, so they've avoided it going out the gate, and also contamination as well can be identified early if you've got equipment set up to spot that. So more information is better, and the manual way of taking a sample was go and grab one every 4 hours or something. Not really fussy about how we grab it. The guy's got to walk out there, bring it back to the lab. He gives it to somebody else to analyse, and it might take an hour or so before that result is available to the control room. And of course, in that time, there's hundreds of tonnes of material that have gone through, and of course, you're hoping that they're still on spec, but it may not be. The better approach, obviously, is to have some at-line sampling where you can sample the stream every few minutes. Sampling is much more consistent, and it's able to transfer that data back to an expert system, which can make some rapid decisions about that information and then make some control action based on that information coming through. So FCT ACTech started developing online analysis equipment over 20 years ago and has built on that experience using the latest advances in computing power and sensor technology to improve the performance of that equipment. So what I'll do is I'll go on now to describe what the at-line analyzers can do and the benefits that we can get from them. So this is COSMA. It was our first online analyzer, and we called it COSMA because that stands for Continuous On-Stream Mineral Analyzer. It combines an arc detector and also with some very good computing power, it can simultaneously measure and present the results of 20 minerals every minute. So it's quite an ambitious project, and these units work very well and very reliably. They use a stream of about 150 grams a minute of powdered material, and that comes into the machine, is analysed, and then goes out of the machine all continuously. And because we use a very large sample, so 150 grams, it's very much more representative of what's going on in that stream. And it's designed for 24/7 operation. It too transmits its data via Modbus back to the plant every minute, so that the plant PLC or the control system can make some decisions about that information and make some corrective actions in the plant. So this is a graph showing some clinker analysis results from a COSMA unit over sort of nearly a 4-day period. So the graph that you're looking at here has got more than 5,000 analysis points on it. So what that is able to do is show us trending that we'd never be able to see before, even a 2-hour manual sampling. So in this particular example, if we look at the yellow line is the free line measurement, and we can see that there's quite a pronounced peak. And what's happened is that the kiln has cooled off for some reason, and as a consequence of that, it's changed the chemistry. And so what has happened is that the lime was not able to combine with the B light to form A light, And as a consequence, we can see those peaks there. So the blue line is the B light. So there's been an increase in the B light because that reaction couldn't happen. And then there's been a decrease in the A light as well. So an enormous amount of information can be gleaned from these charts if you're in a plant and trying to understand what's going on with it. So we have another unit that's measuring the cement coming from a cement mill. And I had a problem 20 years ago when I was working on a grinding plant, and we're having trouble with setting times, and it took us a long time to work out what was going on. But now I've got this information in front of me, I understand it far better. And really what that situation involved was the cement spending too long in the silo and the problems that that created. So for this particular example, it shows various mineral phases of the cement after a cement mill has been restarted from a power trip. So the mill was running normally. There was a power trip. It stopped for half an hour, 3/4 of an hour, I think it was. And then it was restarted. What the problem has been is that when the mill was stopped, there was excess heat within that mill, and it literally cooked the gypsum and liberated water from the gypsum, which created hemihydrate. And then, of course, that water went off to combine with other minerals. So the water did react with the A-light and it created portlandite. So immediately we've got A-light is no longer available for reaction when a customer gets it. So we've got a decrease in strength. So the other thing that we've learned from this too is that once the mill has started up, it's taken nearly 45 minutes to an hour for it to get back to where it was previously. So really that material after that stoppage really should be considered as out of specification and put into a fringe bin. And certainly most people wouldn't have considered that the consequences of a stop to be as significant as they appear on these graphs here. So we've learned a lot of things about these at-line analysis systems and how to put them together over the years. And I'd sort of like to give you some of our learnings that we've got from this work over the years. What we've found is that the analyzers are generally very reliable, but it's the sample handling equipment that needs to be well designed. And obviously the sum of all the parts working together represents the uptime. And if you've got any part not working, it tends to take the whole system out of action. So what we now do is we want to engineer the entire system. So we will engineer systems from the sampler to the sample transport system through the analyzer, and then that return back into the plant as well, because there's things like moisture that can cause problems in the system. And there's also things that go on in the plant that we don't always know about, and sometimes they'll upset the flow of material as well. So what we recommend is that experienced people are used when these sorts of systems are being put together. And one of the other things that we've found too is that the Cosmo analyzer measured a full spectrum. So it can measure its enormous number of minerals, but in reality, most plants, when they measure things, they only need to measure 1 or 2 variables in order to take the control actions that they might need. So what that led us on to is to be able to design some new machines. So combined with the availability of some new silicon strip detectors, we've been able to completely change our perspective on what the sort of equipment looks like. So these new detectors are almost 30 times more sensitive than the previous conventional detectors. And as a consequence of that, it means we don't need as big an X-ray tube. And by having a smaller X-ray tube, we no longer need a cooling system for that. And these new detectors also don't use any gases in them as well, which again simplifies the process. So we're able to simplify the process, reduce some of these ancillary equipment requirements. And because of that, we don't need a fancy room, and we can actually have a smaller footprint, which means that it's easier to put this equipment out into the plant directly underneath one of the sampling points, so that we can make use of gravity and get the sample into the machines very easily, much quicker. And that generally improves the whole operation of the system. So what we've done is we've taken what was a fairly large machine that needed a temperature controlled room, and we've been able to make a far more rugged unit, which can be placed outside. It has its own insulated enclosure. It's sitting on its own return system, and really makes for a much easier and obviously lower cost installation. So just by way of example, the original Cosma analyzer required something the size of a 20-foot container to be placed in. The newer units now go in a much smaller hut, and obviously because of that, their application can be much more easily controlled. So this is showing the different analyzers that are available for the cement process industry. Roger's going to speak in a little bit more detail about these later on, but basically there's a raw meal analyzer, which is used for raw mix control. There is a free-lime analyzer, which is used for measuring clinker and controlling the burning zone and the kiln operation. And there's also another unit which is more specifically designed to measure the gypsum dehydration states and limestone and so forth in the cement grinding. So we'll talk a little bit more about those later on today. So you're probably all familiar with the locations where sampling happens within a cement plant, and this just shows the different types of equipment that can be used in those different locations. So raw meal, hot meal, clinker and cement can all be analysed throughout the system pretty much at real-time intervals. So our new series of analyzers all have a very common sort of footprint. They use very common transport systems between them, and we add and subtract various parts to each of those to be able to perform its duties in the different applications. So they're very quick. Because of that, we can get the material, the results back to the control room very quickly for the control actions. There's a large quantity of material going through, which helps improve the reliability of the results, and that all helps reducing the cost of installation and operation. So underneath the analyzer here is one of the return transport systems. So basically, there are a couple of rotary valves there that make sure that we don't have any interruption of material flow out of the analyzer. And then there's an adductor for some pneumatic flow of that material back into the process. So this is a typical configuration for raw mix control. By reducing the feed variability, there's going to be flow-on savings throughout the whole process, and as a consequence of that, there'll be reduced energy requirements, reduced wear and tear on refractory, and going right through to the cement mill, it's possible to reduce the grinding power consumption as well. So getting things right at the beginning of the process has significant impact on the whole process. So this configuration is showing the sampling of clinker after it's come out of the cooler. we all know that the greatest amounts of energy are being used in the kiln, and so anything that we can do to optimise that is going to help save energy, reduce costs, reduce emissions, reduce maintenance costs, and avoid any off-spec product being produced as well. So very, very important place for sampling. So better control at the cement mill has a number of benefits. Obviously, if the gypsum content can be controlled, and also particularly the temperatures of the systems, then there are going to be more consistent setting times. A lot of places are allowed to add limestone as a cement extender, and because there are limits on that, being able to get closer to the limit means that the amount of material that can be added can be more consistently done without exceeding that limit. And the same applies for other additives like fly ash or slag. So as I showed you earlier, a lot of things can happen in cement mills, but one of the graphs I wasn't able to show you today, but the changeovers, you can watch minute by minute when you change products in a cement mill. And so you can time precisely the point at which you need to change silos when changing between products. So that way you can minimise the amount of off-spec or fringe material that has to be brought back into the system. So we also have these machines set up for other industries because they can measure a broad range of things. It's possible to use in iron ore and copper smelting processes. Again, lots of energy being used, and anything there to help reduce that energy is very vital. So there's a number of different configurations that these machines can be run under. This is just a couple of examples showing a couple of sampling systems. The one on the left is a dry system, whereas the one on the right incorporates a slurry dryer. So in recent years, there's been many manufacturers that have been able to produce lots of different samplers, grinders, jaw crushers, all those sorts of things. So putting systems together now for online or at-line configurations is very, very much easier to do than it used to be. So I just sort of like to sum up the presentation today about variability, and obviously with the introduction of varying alternate fuels and different feedstocks, the variability can suffer quite significantly in a plant. So by having some tools to be able to reduce that variability is very, very important, and advances in technology have helped enormously in recent years to be able to do that. The analyzers are cheaper, smaller, simpler, and much easier to install and operate. The advances in samplers and their reliability has helped a lot, and so too significant advances in control software as well. So what this means now is that we've got the opportunity to reduce the variability in the plants and be more competitive with that work. So that concludes my presentation, and thank you.
So thank you very much, David, for your impressive talk. So for those in the audience who want to ask some questions, then please feel free to type it in the Q&A dialogue. I have already one question there. David, how do you estimate the, let's say, the requirements for an owner of such a system in respect of maintenance? So what do you expect? What is the time per week, per month people have to spend to keep this machine up and running?
Look, it varies depending on what the material is. Obviously, if it's a raw meal application, there's very little required. I mean, there'll be an occasional amount of cleaning and inspecting just to make sure there aren't blockages and things. and providing the installation's been well heat traced, well lagged, there's usually not very much to do. So it's really just a shift person running past, spending maybe 5 or 10 minutes just to check that everything's going okay, and then they can be on their way again. Obviously, some of the clinker applications where there's a grinding and crushing going on, the wear on those parts can be a little bit higher. So again, just coming through, checking it on a regular basis is important. Again, it's going to depend on what the equipment is and how much, I guess, material was going through there as to what sort of maintenance might be required. I mean, for the analyzers, the preventative maintenance is usually done on a 6-monthly interval. And again, that might require it to be down for a shift or something for that sort of work. And I would presume samplers may be similar to that, but sometimes samplers can go a lot longer without requiring much maintenance.
Okay, thank you very much. Then I have a second question from Bruce. How should the RMX be calibrated? Do you still need to operate a lab XRF when you have this online system?
Yes, that's right. So we've got some experience with one of the large manufacturers. They have proprietary software that they run. And also there are some independent third-party suppliers of software. And what they do is they compare the analysis results from the machine to a lab sample that's taken. So incorporated into the sample return system that we have is a diverter. So we're actually able to collect a composite sample every 4 hours. That sample is then taken back to the laboratory, analysed with a lab XRF machine, and then those results are fed into the software. And the software will take up any drift correction that may have occurred in that time. And so we don't actually need to make any adjustments to the analyzer. The software takes care of that at a plant level.
Okay, thank you very much. Then a third question about, can I use these analyzers also for 2 or more material streams? Or in other words, can I do a multiplexing?
Yes, that is possible. And it really depends on what the distance is between the 2 sampling points, because we've done some of these in the past, and the difficulty has been with the material transport system getting it to the machine. So it would need to be worked out on a case-by-case basis. So what would normally happen if it was 2 streams, the analyzer would probably run on one of those streams for about 25 minutes, then it would change over and purge on the other material for about 5 minutes, and then it would repeat that cycle between the 2. So really it's going to be worked out on how far and what's involved in getting the sample from one site to the other to the machine and where to put the machine. So sometimes the sampling equipment can be costing more than the analyzer, so you might as well just put 2 in, and then it's going to be far more reliable.
Okay, so thank you very much. I think that was it for the time being. For people that didn't dare to ask right now, there will be later or after the workshop, there will be another time slot for